Good morning, everybody. In continuation with our previous topic of speed and velocity, today we are going to cover an example of speed and velocity, which will differentiate between speed and velocity. Secondly, we are going to cover effect of speed and direction on velocity. Thirdly, we are going to cover uniform and non-uniform linear motion. And fourthly, we are going to cover acceleration. So let's begin. We are going to cover first an example of speed and velocity difference. Now this is Sangeeta's house A, this is Pallavi's house B, this is school C. Now Sangeeta travels a distance of 500 meter and reaches to Pallavi's house. Then she covers a distance of 1200 meter and reaches to school. She covers a distance of her home to Pallavi's home in 5 minutes. And here she takes 24 minutes to reach school from Pallavi's house. Now what is speed here? What is the speed of Sangeeta? It will be total distance travelled upon total time taken. But if you want to find out speed from A to B, it will be distance travelled, which is 500 meter, total distance travelled upon total time taken, which is 5 minutes. This comes out to be 100 meter per minute. What is the speed of Sangeeta when she goes from Pallavi's home to school? Speed BC is how much? Total distance travelled, which is 1200 meter upon time taken, which is 24 minutes. This comes out to be 50 meter per minute. If you will calculate it. So what is her average speed? Her average speed will be total distance travelled, which is 1200 plus 500, and total time taken, which is 5 plus 24 minutes. This is 1700 upon 29. This comes out to be approximately 58 meter per minute. Now we have taken average speed as total distance travelled. So we have added the total distance 1200 plus 500 and we have divided it by total time taken, which is 5 plus 24 minutes. We have not done the average by adding 100 plus 50 and dividing it by 2. May I know why? Yes, because the denominator in both the speeds are different. It's 5 minutes, it's 24 minutes. So we cannot average it out by adding 100 plus 50 divided by 2 because the denominators are different. So average speed will be total distance addition of total distance and addition of total time. Now what is velocity? Suppose Sangeeta travels from A to C directly to school without going to Pallavi's house. We know by Pythagoras theorem this distance will be 1300 meter. This is a right angle triangle. So this distance will be square root of 500 square plus 1200 square, which comes out to be 1300 meter. So suppose Sangeeta travels the shortest distance A to C, which is a straight line, 1300 meter. So this AC, we have already discussed this in our last session, that velocity is displacement upon time. So what is the displacement here? It's the shortest distance between the 2 points, starting point and finishing point. So the shortest distance travelled by Sangeeta would be 1300. But Sangeeta took 29 minutes to reach school. 5 minutes and 24 minutes. So the total time taken was 29 minutes. So this comes out to be approximately 44 meter per minute. So you can see the speed is 58 and velocity is 44. Speed and velocity are different. This is exactly what this page was trying to say. So the average speed was 58.6 meter per minute, which is 1700 upon 29, and velocity was 1300 upon 29, which comes out to be 44.83 meter per minute. Now let's move on to our next topic, effect of speed and direction on velocity. Now suppose Prashant moves in a bicycle in a straight road, on a straight road. But he applies the brake and the speed slows down. So speed is changing. When speed increases or decreases, then velocity, keeping the direction constant, he is moving in a straight line. Then velocity also increases or decreases. Now, at the turn, he changes his direction, but speed is constant. Direction changes. But speed is constant. Then what will happen? Yes, velocity will also change because direction is changing. In the third scenario, he decreases his speed and also changes the direction. So direction changes speed changes, so velocity, yes, velocity will also change. So we have described the effect of speed and direction on velocity. Now let's move on to our next topic, uniform and non-uniform linear motion. Before that, there is a small snippet which says that the first scientist to measure speed as distance and time was Galileo. The speed of sound in dry air is 343.2 meter per second, 343 meter per second, while the speed of light is about 3 into 10 raised to the power 8 meter per second. The speed of revolution of the earth around the sun is about 29,770 meter per second. So speed of revolution is greater than the speed of sound. So you need to remember these figures. Moving on to our next topic, uniform and non-uniform linear motion. So now let us say there are two friends, Amar and Akbar. Amar and Akbar decide that they are going to go to another town and come back by visiting that town. Now, suppose they both start at 5 o'clock. So, in half an hour, that is at 5:30, the distance covered by Amar is 20 kilometers and distance covered by Akbar is 18 kilometers. They both travel this and calculate the distance they cover in every half an hour. So, by 6 o'clock, while Amar has covered 40 kilometers, Akbar has covered 36 kilometers. So, what we do is, we try to understand what is their speed, how much distance have they covered in equal intervals of time. So, when we plot the speed, plot the distance upon time, we see that Amar has covered equal distances in equal intervals of time, whereas Akbar has covered unequal distances in equal intervals of time. So, the red graph is red line, red slope belongs to Akbar and the blue line or blue slope belongs to Amar. Now, this is distance and this is time. Distance and this is time. So, we see that at 6 o'clock, between 6 o'clock and 6:30, while Amar travels straight with a straight slope, that is, he covers equal distances in equal intervals of time. You can see that he moved from 40 kilometer to 60 kilometers between 6 to 6:30, whereas Akbar covered 36 kilometer to 42 kilometer. This is the line, says 42, and this is 36. So he covered only 6 kilometers in half an hour, whereas Amar covered 20 kilometers. So we are trying to say that the slope is different. The distances are uneven. So these distances which are uneven in equal intervals of time, this kind of motion is called non-uniform motion, or we say Akbar was moving with non-uniform speed, because distance time graph slope gives an idea about speed. So we can say if an object covers, or if a person covers, or an object covers equal distances in equal intervals of time, he is moving with uniform motion. But if an object covers unequal distances, in equal intervals of time, we say he is moving with non-uniform motion or non-uniform speed. So we saw that how Akbar, due to traffic, he met a lot of traffic in between. So he was not able to cover the distances that Amar covered. So he moved with non-uniform speed. Now let's move on to our next topic, which is acceleration. Now, to understand acceleration, we take an example of a tube from where we drop a ball. We release a ball alongside the tube, and we see the tube is slant in height. It is slanting. So the ball hits the ground after some time. Now when we release the ball was at zero speed or zero velocity. See, it's a straight line. We released it, this tube is straight. So we released it from the top and it moved alongside the tube and hit the ground. Initially its velocity was 0. When we released it, we saw its velocity increase towards the end, and when it reaches the ground, the velocity becomes 0. So this change in velocity with time is called acceleration. So initial velocity, if initial velocity is u, final velocity is v, and time taken to travel this distance is t, We say acceleration is equal to final velocity minus initial velocity upon time taken. We saw that the velocity is not same at all the points. It was 0 initially, then it increased towards the tube, towards the channel, and when it hit the ground, the velocity became 0. So this is called rate of change of velocity is called acceleration. Now we are going to cover positive and negative acceleration and uniform and non-uniform acceleration in our next topic. We end this class today and let's move on to our next topic in the next class. Thank you. Goodbye.